Our team name is called Gliese-514b. The goal of our project is to create a secure, autonomous robotic environment containing two components, a UGV and a UAV. This is important because this project demonstrates a concept that is fundamental to security of autonomous technologies. In this video, we will be discussing how our team was able to work towards our goal of connecting a UGV and a UAV. Let's begin with the UAV. Here's our UAV. Here we have the flight management unit, and underneath we have the companion computer, the NavQ+. Between these two components, we are able to organize all the sensory data we get from the GPS, the gyroscope, and the compass. So the flight management unit controls the motors, the 4 motors. Here we have the NavQ+, where we'll be running native Linux. On the NavQ+, we will be using the Wi-Fi module built in. We'll be using the camera connected by PCIe cables, and we'll be using the built-in Linux to run a multitude of programs, including Python and C scripts.
Alright, hi guys, my name is Matt and I'm part of the UGV Construction crew. This is the UGV that I built. This is what we're going to be landing our drone on. The reason we went with acrylic is because originally we wanted to use aluminum, but aluminum was going to be too costly and a little bit too heavy for us to use with these motors. Now, the wiring here, we have a Xilinx Pink Z1 board that is controlling all of the logic of our UGV here. So we do have a motor control team and they're in charge of coding the FPGA, the Pink board. So I have just done testing with this system and all 4 of these motors, and I've gotten them to spin myself. But the motor control team is going to be controlling the logic and implementing the differential steering. That's also why for the design we wanted these wheels to be as close together as possible without touching, because the farther apart these wheels are, the more slipping that occurs. And when we have slipping, we lose power. And when we lose power, we run our battery out faster.
I'm Pacheco. I'm on the GPS team. The overarching goal of the GPS team is to gather the NV data and transmit it to the encryption team. And then they would transmit it to Wi-Fi team and send it over to the drones. This is the payload of NV data that comes every second. We only want one of these sentences. So I'm gonna run this Python program, and if we look at the terminal, we will see that we're getting only one string of data. That is the GGA, which will give us our longitude and our latitude.
Yes, I'm Colin and I'm on the Wi-Fi team. And our job was to create a wireless communication between the UGV and UAV. First thing we wanted to do was to create it straight on FPGA by using Vitis, but C code through Vitis is very complicated and complex. So we decided to go through this way by secure shelling in to the Linux system and running the Python program. It is done by using the socket libraries, and we were able to send text messages between the UGV and UAV.
Hi, my name is Omar Briano.
My name is Shrikanth Shivakumar.
And we're both a part of the LIDAR and computer vision group. We interfaced our LIDAR sensor to measure distances in feet and set a bit in a specific register depending on the distance measured.
The servo motors will sweep back and forth in a 180-degree arc, and when the sensor senses something within 10 feet, the motors will stop and hold the position.
When an object is detected by the LIDAR sensor, it will hold its position, and once the object moves out of its way, the LIDAR will then continue its sweep.
Hello, my name is Estevan Flores. I am part of the encryption team, and my job was to implement the Tiny Jambu encryption code here. Tiny Jambu is a lightweight encryption algorithm that was one of the finalists in a NIST competition about 2 years back. The Tiny Jambu algorithm is going to be at the forefront of sending all of our information from our UAV to our UGV. We planned on running the Tiny Jambu algorithm on an operating system called Pentalinux. With the use of the Pink Z1 and the Pentalinux operating system, this was going to integrate sending and receiving information for computer vision, the LIDAR, to our Wi-Fi modules, and even our GPS information. Pentalinux is the final step of integrating all of our teams into one house.